Okay, let's be real. You see a huge word problem and your brain just freezes up.
It's super intimidating, right? Just this giant wall of text. Sounds familiar? But here's the thing. The math itself isn't what's tricky. The real problem is hitting. See, it's really just a translation problem. You're just turning plain English into math. And here is the absolute golden rule. The answer is always hiding at one of these corners. And get this, there's a foolproof method that solves every single one. Same 5 steps every time. So let's break it down. Step 1, define your variables. You gotta know what x and y are. Second is the objective function. Basically, what's the goal you're trying to max out or minimize? Third, you write your constraints. These are the rules of the game, written as inequalities. Fourth, you graph it all. That sweet spot where all the shaded areas overlap, that's your feasible region. And finally, step 5, test the corners of that region. Your best answer is right there. Okay, theory's great. Let's see how this actually works with a classic exam problem. So our goal here is to get the biggest z possible, but we have to play by these rules. First up, we graph the lines for our constraints to find that all-important feasible region. Now this is key. To find exactly where lines cross, solve the equations. Don't just eyeball it. With our corner points found, we just plug them into a simple table to test them in z. And boom, the table shows us the winner. The maximum value for z is 21. So to recap the 5 steps, define, objective, constraints, graph, and test. That's the whole game. You now have the key. So the real question is, what else can you solve with this?